Hey guys, and welcome to another video all about how we can use systems of equations to model some real-world situation. So in this example, the question we're asking is, who is the better employee? So you're the CEO of a digital marketing company, and you have two of your best employees. We'll call them Terry and Julie, and they do sales. And you know how long each of them works each day, and you know how many sales they make in total together, but you want to know how many sales each of them makes individually so you can decide whom to give a raise and promotion. So here's some information that you collected last week. On Thursday, Terry worked 8 hours and Julie also worked 8 hours, and together they made 104 sales. Again, you don't know how much Terry made or Julie made, but you know that together they made 104. On Friday, Terry worked 6 hours, Julie worked 5 hours, 1 hour fewer, and together they made 73 sales. So again, you know how much they made together, but not individually. And so the question you want to ask yourself is, how many sales are each of them making per hour? And you decide that this is the best indicator of who the better employee is, of course, in your opinion. And so my question is, do we have information to figure out exactly how many sales per hour is Terry making and how many sales per hour is Julie making, knowing only the total number of sales they made and how many hours they worked? So here we go. Here we go. If we knew that Terry made X sales every hour, then how many sales did she make in the 8 hours she worked on Thursday? Well, if Terry made X sales every hour, then in 8 hours she would make 8 times X sales, right? So on Thursday, who is this? Terry? Terry would have made 8X sales, right? 8 hours times X sales per hour this is how many sales she'd make. For Julie, the same day, well, if she makes Y sales every hour, how many sales did she make in the 8 hours she worked on Thursday? Well, 8 times Y. 8 hours times Y sales per hour. And note to self, I guess we've already defined our variables. X is going to be Terry's sales per hour, and Y is going to be Julie's sales per hour. And in general, whenever we are defining our variables in order to create some equations and eventually find out some information, how do I typically define my variables? I define them to be that which we don't know and that we'd like to know. And what you want to know is, how many sales are each of them making per hour? So that's what we're going to define our variables to be. X is going to be the number of sales that Terry makes every hour, and Y will be the number of sales that Julie makes every hour. Okay, not so bad. So, can we create an equation to describe all the possibilities for how many sales per hour Terry and Julie make, given the fact that when each worked for 8 hours, they made a total of 104 sales together? So my claim is, all we're doing is taking the fact that, listen, on Thursday, Terry made 8X worth of sales, or 8X sales. And Julie made a total of 8Y sales. We don't know what X and Y are. We don't know how many Terry made per hour or how many Julie made per hour. But we do know that this is the total number of sales they made, and that had to equal 104 on Thursday. This is Thursday we're talking about. Okay, well, we've now just created one equation relating these two unknown quantities, these two unknown variables, how many sales per hour Terry makes and how many sales per hour Julie makes. Phenomenal. If we can make one more equation, we're going to be ready to rock. So let us continue. Once again, we have the exact same variable definitions from before. So if we knew that Terry still makes X sales per hour, how many sales did she make in the 6 hours she worked on Friday? Well, on Friday she worked 6 hours, so she must have made 6 hours times X to X sales per hour. So this is how many sales Terry made. Well, Julie makes Y sales per hour. How many sales did she make in the 5 hours she worked on Friday? Well, 5 hours times Y sales every hour, she's going to make 5Y sales. So this is what Terry did. This is what Julie did. And this is the total for Friday, for the two of them. Okay, phenomenal. Well, now let's try to create an equation here. We've got an expression to describe all the possibilities for how many sales per hour Terry and Julie make per hour. Well, given the fact that we know they make 73 total sales, so here is the Friday total. We just mentioned that. This is the total number of sales that the two of them make on Friday, and we know that that needs to equal 73 total sales. So what we've done here is we've created another equation relating these two variables, X and Y, these two unknown quantities, how many sales per hour Terry makes, how many sales per hour Julie makes. Now we have two equations, two unknown variables. It's a system of equations we should have no problem going ahead and solving that. So let's go ahead and make that happen. Now, when I take a first look at this, I'm thinking that the best course of action is probably either the elimination method or substitution method. I'm going to go ahead and use the elimination method. I think you could use this equation to do the substitution method, but let's do elimination just because I want to practice different strategies here. And I think that the easiest variable to eliminate in this case might be our x's. So I'm going to multiply both sides of this top equation by -4. I'm trying to get a -24x here. That's kind of the goal. And I'm going to multiply both sides of this bottom equation by 3, so I get a positive 24x here. And then they'll add to 0. So we end up with -24x. Let's see, minus 20y. Y equals, let's see, 73 times -4, -292. Awesome. Make that 9 a little bit clearer. Okay. Let's see. So 8 times 3 is 24x. Ding, ding, ding. That's the whole idea. 8 times 3 is, again, 24y. And that is all going to equal 104 times 3 is 312. All right, so here we go. So we're going to add, 312 to both sides of this original equation. Our x's are going to eliminate. That's phenomenal. We get 0 plus 4y. So 4 times however many sales per hour Julie makes is going to equal 20. Oh, divide both sides by 4. So we end up with y equals 5, meaning that Julie makes 5 sales every hour. So now we got to find out how much Terry makes. And let's do it using either of these. So I'm going to use this equation right here. And so we know that 8x plus 8 times, 5, that's how many sales per hour Julie makes, is 104. 8x plus 40 equals 104. 8x equals 64. X equals 8, meaning that Terry makes 8 sales per hour. Now let's just confirm and make sure by substituting these into our other equation, make sure we don't make any computational errors or whatnot. So 6 times 8 is 48. Plus 5 times 5, which is 25. 48 plus 25 is indeed 73. So we are relatively confident that we have solved this system of equations correctly. It appears that Terry makes 8 sales every hour. Julie makes only 5 sales every hour. Sorry, but Terry, she's the one who's going to be getting the raise because she appears to be the more productive employee in terms of making more sales per hour. So again, our general strategy was, let's figure out that which we don't know, and let's define some variables. And then we're creating expressions and eventually equations, 2 of them in total, in order to create a system of equations which we can then solve using any of the methods we discussed before in order to find the specific value of both of these variables. So I hope you enjoyed, and I hope you found it helpful.